Hi, I'm Pat. All right, this problem starts us off with a graph, and they describe to you that what's provided is one period of your good old familiar f of x equals sine of x, right, here in red, and then also a period of this graph, y equals sine of x minus c plus d, and they want us to find the values for c and d, okay? All right, what this comes down to is our horizontal and vertical translations, right? Hope you're recognizing that just in the format of this expression. So let's go to the graph. And of course, with all of our transformations, whenever we're doing something like that with a graph, the new image, in this case the green, looks like the original, right? So these are both very much the same kind of sinusoidal graph, the S shape. Okay, but we're going to try to pin down exactly how much they differ. Okay, all right, so the key is just to try to line up the corresponding points. For instance, the start of your sine of x graph is good old 0, 0, the origin. So the corresponding point in this graph is pi over 4 as your x-coordinate, comma 2. Okay. And now let's make a more general observation in terms of each of these points in your original graph. Let's just start with the horizontal, so left or right. How much do those points move over? So the first one we observed already, 0, 0, moves over to the right, pi over 4 units. All right, your x-coordinate here, your first coordinate is pi over 4. Right? Is that true everywhere else? You can grab each of your other corresponding points of the graph that you know. Here's an easy one to grab, right? This is pi, comma 0. You know that with your sine graph, right? If this is pi, comma 0, the corresponding point up here is 5 pi over 4, comma 2. But let's look at that first coordinate. So you've moved from pi as an x-coordinate over to the right, pi over 4 units, right? So this point in our image graph is pi over 4 greater than this original graph's x-coordinate. All of this thinking is actually honing us in on this value of c. c is the horizontal translation amount, and what we just figured out is that c equals pi over 4. Now, I want you to confirm that. I was talking you through a couple specific points, but any other point you wanted to grab, you'd be able to do the same thing. So like this last point that's drawn for me in one period of the original sine graph is 2 pi, comma 0. Notice how this corresponding point has an x-coordinate that is pi over 4 greater than 2 pi. That's how we're getting this value for c. Okay? All right. Next, let's get a value for d. And d, according to this format of our image graph, is the vertical translation, right? That plus d outside of your trigonometric function represents the vertical distance up or down. So let's go back to these points. And again, I can pick on 0, 0, but this time I'm going to focus on the y-coordinate. It was 0, now it's up to 2. Is that true everywhere else? At pi over 2, the y-coordinate of the original graph is 1, right? And the corresponding point would be here, and notice the y-coordinate has increased by 2. These y-coordinates of every green point of the graph, every point of the green graph, is 2 units greater than the original graph. So my d value is 2, okay? That's what we're doing, is just trying to compare where we were to where we are now. Red is where we were, green is where we are now. Express your horizontal changes, the differences in the x-coordinates, as a c value, and express your vertical changes, the differences in the y-coordinates, as your d value. And so then my final answer here is y equals sine, parentheses, x minus pi over 4 plus 2. Just putting c and d in place, okay? All right, good. I'm also going to throw one quick word of warning at you for a different problem you might do down the road on your own, because I know you're going to practice them on your own, right? Be careful of that subtraction sign. Your value of c is the amount that the image graph is shifting to the right. So in a different problem, if you see your image graph, the green guy here, if you see it moved to the left, you could very well have a negative value for c And so you'd be subtracting a negative, and that would end up giving you a plus on the argument on the inside of the trig function, okay? Just watch for that. Okay, but of course, practice.